Hi and welcome back. So today, for this video, I thought it would be a good idea to show a little trick you can do with using a single lamp bulb, like a mains bulb. Pretty much like one of these, just a standard domestic lamp. These days, they're a little bit harder to find now because everybody switched over to LED high efficiency lamps, but you can still get them off the internet and places like that. It needs to be a filament type, you know, like a standard incandescent bulb, like the good old-fashioned ones, where you've actually got like a heater inside, a filament inside, not an electronic LED type. Now, so what can we do with a lamp bulb as a piece of test equipment? And well, this is something I picked up some years ago when I was working with, well, I still am working with vintage amplifiers, like musical instrument amplifiers for guitarists and sound systems, you know, PA sound systems, that sort of thing. And a lot of times when you first plug the equipment in and you test it, if it's old and it's been standing around, or it's got a fault inside, you know, if you just plugged it into the mains and you switched it on, it would usually just pop the fuse. You know, something was wrong, so then you'd have to like put another fuse in and then do it again and work your way through it, and it just got a little bit tiresome having to change fuses all the time and waste money changing fuses and probably doing more harm than good in the process. It's not a good way to do it. So I came across this idea, just using a bulb, and all it really is simple lamp bulb, like I say, incandescent bulb, and it's in series with the live of the mains. It's as simple as that. It's all it is. It's just in series with the mains coming in, goes through the bulb, and then I've got like a socket here which comes from the bulb, and I've got this plugged in, which is a 12 volt 13.8 volt CB power supply, which has been modified. It's got some extra capacitors in there to make it a bit more, give it a bit more current. This will deliver about 5 amps. That's a linear power supply, with a transformer in there. That's the transformer there in the middle there. So it's a reasonable. It's fairly chunky and quite heavy. So the idea is, if there's a fault, if this is the unit under test, something that you're trying, if there's a fault in there, it'll actually show up on the bulb and it won't blow any fuses. All of the current then goes to the lamp instead of to the unit under test. So don't need any fuses in line. There's no need. There's no fuses to blow. There is a fuse in the unit itself, just there, but that won't blow even if it had a fault, because everything would go to the lamp. So what we're looking for is a bright light when you first switch it on, and if that happens, there's a short circuit either in the primary or in the secondary of the transformer, or somewhere in the regulator circuit coming out. So it's a really good way, it's a neat way of figuring out if there's a problem with the unit. The other thing is, when you first switch the unit on, in this particular case we've got smoothing capacitors in here, about 10,000 UF or so in here, and what you will see is an inrush current when you first switch it on, because these are now discharged, it's been left off for a while. And what we should see, well, a healthy sign would be the bulb briefly, like half a second, going bright, then going dim. And if it does that, it means that the that's correct. It means that the smoothing capacitors have then charged up to where they would settle to, and the voltage would rise, and it means everything's fine. So let's try that first. So we've got the mains coming in, the live goes through a simple bulb. This is just a mains board here, just so I can connect into it, and then that plugs into the unit under test. Don't forget, this could be an amplifier, it could be a radio, anything really that runs on the mains. Okay, so let's switch it on, and let's see if we can just watch this lamp. I'll turn my bench lamp off. So here's the lamp there. Let's try this on. We're looking for a quick flash. Let's try it. And that was it. Did you see that? I'll switch it off and we'll try it again. I'll let the the unit discharge a little bit. Might take a while, so I'll just give it a few seconds. And that's a really good sign. It means it's working. There's no short circuits. Switch it back on again. Now you notice this time it didn't actually flash. But however, I don't know if you can see that or not, but the lamp is actually glowing very dimly. Can you see that? It's just barely on, like a little orange glow. So there is a little bit of residual current going on. But that's perfectly fine. Now let's just check everything's actually working. So I've got my my voltmeter here. Let's see if the power supply is actually doing anything. Yeah, 13.6 volts. 13.66, and it's supposed to be 13.8, so it's quite close. So the supply is actually working, but it's only because we're not taking any power. Now then, haha, here comes the fun part. I'm going to use a crocodile clip to demonstrate some shorting out, as if there was a fault. So I'm going to create a fault into the system. And don't forget, you'd never actually do this unless you have the bulb in line and you know what you're doing. You need to be competent, because don't forget, we're working with mains voltages here. Very dangerous, so that's the disclaimer right there. So please be careful if you do this kind of thing. You need to sort of know what you're doing. So here we go. I'm going to put the crocodile clip first of all, just make a bit of room here, and I'm going to put it across the output terminals of the power supply to create a short circuit, which would indicate, well, simulate something in the regulator circuit. So let's try that. I'm going to short the output of the supply, and there's the lamp. See that? And that's it. So if there was a fault in there, the bulb would be on bright, and we haven't blown any fuses, nothing's exploded. It's all pretty safe. Now I'm going to do the same thing inside of the power pack itself. Get out the way. See if you can see this. Now don't forget, very dangerous. 240 volts coming in this side, and about 30 or 20, between 20 and 30 volts coming out that side. Please be very, very careful if you do this kind of thing. So here we go. I'm actually going to short circuit first of all the secondary of the transformer to show or simulate a shorted turn inside of the transformer itself, which can actually happen as a real life fault. You can get, you know, the windings of the transformer can actually short out. So let's simulate that. Here we go, shorting out now. Okay. And normally you could never do that. It would blow fuses and all sorts of stuff, and you get a big spark. So that's on the secondary, simulating a short circuit on the secondary. Now, this is the most dangerous part. Let's go to the primary and short out the primary of the transformer, which again can happen. You can get shorted primary turns. So let's do that, being very careful here with my fingers. And there you are. That's shorting out the primary of the transformer. So that's primary short, secondary short, and output of the actual regulator of the whole supply short. Very handy. No fuses blown, and if we actually plugged this in and the light came on bright in the first place, we would know that there was a short circuit somewhere within the device, and then we can investigate further using maybe a variac control to slowly ramp up the mains or something like that. But it's just a simple lamp bulb, and I hope you find that a useful trick. Like I say, it just goes in line with the mains. I've got this all completely insulated. I've got heat shrink tubing on it and all sorts of stuff. You should probably have like a proper holder, you know, with a bulb that goes into the holder. Another handy feature would be to have a switch which bypasses it, which shorts out the lamp. So then you could go from a safety position with the lamp in series, then you could go flick the switch to full power, and then you could test the device on full power after that. That's another modification you could do to make it slightly better. I hope that's been useful. Very handy tip. It's almost a secret in a lot of vintage repair circles. You don't really hear about it very much, but it's really simple and it's incredibly effective.